Hello everyone and welcome to this British Plastics Federation webinar. My name is Paul Baxter and I will be your host for this webinar. The topic for today's webinar is overall equipment effectiveness, and I'm delighted to welcome our speakers for today, who are John Hardwick, John Hill and Alan Finlow. John is Director of InTouch Monitoring, John Hill is Chief Operating Officer at InVMA, and Alan is Managing Director of Haley 247 Engineering Services. John, if you'd like to move to the next slide, which shows the full biography of our speakers for today. So you can see all of their backgrounds. So John is co-founder and managing director. John is the COO in VMA, and Alan is the founder and managing director of Drive Management Services, a part of Haley 247 and the Dexis Group. So before I hand over to our speakers for today, just a little bit of housekeeping. I wanted to mention to you all that if you do have any questions, our speakers would be delighted to answer them. If you want to submit them, please use the online tool in your control panel, and I will pick these up and I will put the questions to our speakers at the end of today's session once we've had the three different parts of the presentation. With that, that's all my housekeeping. So without further ado, over to you, John.
Okay, thank you. Thank you, Paul. So thank you all for taking the time to be here today. I think that time's more valuable than money these days, so I don't take it lightly that you're spending some of it with us. So I'll keep my introduction fairly brief, and perhaps I'll try and squeeze in a small plug for our services at the end. So I'm John Hardwick. I'm Managing Director of InTouch Monitoring Limited. My background is in manufacturing in the plastics industry. So I started out straight from leaving school. I went into blow moulding at Smith's Containers in Risdon. I moved on to injection moulding at Thurgood Bolly in Kettering, and I ended my plastics processing career at Superboss Packaging in Tamworth. And that was about 20 years ago. Now, most of my time was in production, in the production department, but I also spent time in supply chain, and I was always dabbling in the IT. And during my time in manufacturing, I implemented a number of different MES systems. I was also heavily involved in some ERP implementations. Part of my journey was in production planning, and I was constantly battling between sales and production, trying to make things as efficient as possible for the production department, and at the same time trying to keep sales happy and trying to meet our customers' deliveries. The plans normally made sense, but we never really quite achieved them, and that's where my interest in OEE comes from. There was a problem there. I needed to find out what the problem was and what we could do about it. So, what does it mean and why bother? Excuse me, I've already lost my space. So, that's better. OEE, what is it? Overall equipment effectiveness, or OEE, is simply an expression of how much product you have made compared to the maximum amount of product you could possibly have made in the given time. Wikipedia gives a very similar definition. It says OEE is a measure of how well a manufacturing operation is utilised compared to its full potential during the periods when it is scheduled to run. So it looks at how well you are utilising your equipment, so essentially downtime, or in OEE terms, the availability. It looks at the speed you are running at. Are you running at standard or slower? So the cycle efficiency or performance. And it looks at how much scrap you are producing, so the yield or the quality rate. I should say that during my first attempt at this presentation, I focused quite a lot on calculations, and I ended up with something that was very dry that I'm sure that sent you all to sleep very quickly. So I've changed the approach a little, and I'm not going to go into the maths in any detail, but try and give a more general overview, and that will hopefully generate some enthusiasm towards implementing OEE. So when talking about OEE, people often say, are we world class? But what I'd like to say is don't get hung up on the number. OEE is not about being world class. It is very much a tool to improve your productivity. I think this could be probably one of the most important messages from me today. It's a bit simplistic, but if you chastise your workforce because your OEE is not world class, because it's not 80 or 90%, whatever number you're chasing, they'll spend their time finding ways to manipulate the numbers to keep you happy. And it can actually have a detrimental effect on your productivity. In my experience, many companies really struggle to even reach 65% OEE if they're measuring it accurately. I've worked with many companies that have claimed OEEs of 85% or even 98 and 99%. And the reality is that for the most part, they are a long way away from that. And I do get it. If your boss is asking you to measure your OEE, do you really want to go and tell him that, no, it's 45, 46%? How can it possibly be that bad? We might not be world class, but can we be that bad? Will I get replaced with someone who can do better? And so I think it's really important to not use OEE as a big stick. It is a powerful tool to measure improvement. And if you operate in the environment where you are using it as a big stick, then it's going to lead to manipulation of the data. People are going to be trying to manipulate the numbers to sort of keep you happy. As I see it, when you introduce OEE to a business, the lower it is, the better. This just means that there's greater gains to be had. So why use it? It tells us if a piece of equipment can do what it's meant to do, and if it will enable you to deliver what you are meant to deliver. So as I say, it's not a big stick. What it's really good for is helping you identify what your losses are and what is causing them. So if you are not meeting demand and are operating at a low OEE, you know that there is room for improvement. If you are not meeting demand and are operating at a high OEE, you know you've got a capacity problem. And even if you are meeting demand with OEE, you know if there are improvements there to be had. And at a really high level, I like these statements, but we need to delve deeper to understand where we are losing out and what we need to do to improve. And this is where OEE really shines. When used correctly, it's an excellent tool to help you understand your losses and drive improvement. And it can also be a really good educational tool and be really quite motivating for the whole workforce. So how is it calculated? I think anyone that's even lightly touched OEE knows that OEE equals availability times performance times quality. And if you don't know this, then I'm probably going to be missing some stuff out. But hopefully, as you're here, you do know the basics. But if not, there are lots and lots of resources available online. We've got quite a nice little simple OEE explainer on our website, and there'll be a link to that at the end of the presentation. So in collecting OEE, we need quite a lot of information to calculate it. So downtime reasons and durations, scrap reasons and quantities, cycle times and production quantities. And collecting all of the data manually is very time consuming and will not be very accurate. As an example, typically if a machine stops for an hour, your guys will fill in their timesheets with the details, but if it stops for 2, 3 or 4 minutes, they probably won't. It takes as long to fill in the paperwork as it does to restart the machine. So it makes a whole lot of sense to collect the data automatically if you can. It will be far more accurate. And it can also be quite costly actually to do a good job of collecting data manually. The operator will spend time filling in a downtime sheet and scrap sheet for each machine. Team leader will then collect that information into totals for the shift. The supervisor will then probably enter that information all into a spreadsheet, and hopefully one day somebody will actually look at it and analyse the data. But there's a huge opportunity for error, and people spend all of their time collecting the data rather than actually analysing it and doing something with it. I've had many occasions when the justification for buying an MES system is based purely on the time saved collecting data manually. And really with OEE, that really is just the tip of the iceberg. Once you've actually collected the data, Having an understanding of how OEE is calculated will help you understand where the losses are coming from and point you in the right direction to where improvements will make a difference. And when it's presented well, the data can very clearly highlight this. If it's used as an improvement tool and as an educational tool, then you can get the whole workforce behind it. So OEE in itself is quite a useful benchmark, but we do need to dig further to be able to analyse where our losses are and what we can do about them. So as mentioned, I'm not going to go into the maths in any detail, but it is important to understand that OEE is a ratio and so can therefore be derived from any relevant units. It can be very powerful to express it as a ratio of durations, how those losses relate to time. And lost time is something that's very tangible. So we said that OEE equals availability times performance times quality. So it's made up of those three distinct KPIs. So availability, was the machine running? Performance, was it running slowly? And quality rate, was it producing scrap? And if we try to stick to representing the information as times, it can be very nicely represented by what we call the OEE staircase. So starting with availability, the availability rate is a measure of how successful we have been in keeping the machine running, simply calculated as a ratio of run time to available time. And so this, on our staircase, we're highlighting the losses due to unplanned downtime. The performance is a measure of how well the machine ran when it was running in terms of rate of production. So it's a ratio of the parts made to the number of parts you should have been able to make in the given run time. I've got here performance equals standard time produced divided by run time. So that's essentially, it's just converting the parts made into time. So parts made times standard time or standard cycle is the time it should take to make the parts you made if the machine is running at its maximum possible rate. So we call that the standard time produced. And quality rate is the ratio of good parts made to total parts made. And again, we represent this on our staircase as time spent producing scrap or standard time scrapped, and time spent producing good parts, so standard time earned. So it's good to notice the difference there on our staircase between standard time produced, which includes both good parts and reject parts, and standard time earned, which only relates to good parts. So you can see that the productivity of the machine is broken down into a series of ratios of time periods. So the availability equals the run time divided by the available time. Performance equals standard time produced divided by the run time, and quality rate is the standard time earned over the standard time produced. We know that OEE equals availability times performance times quality, and therefore it equals standard time earned divided by available time. And there is, so I said I wasn't going to go into the maths, there is a breakdown of all of those calculations on our OEE explain page. But the staircase is a great way to look at how the different losses chip away at the time you had available to make a good product. So we can add one further level to our staircase and include planned downtime. Near the beginning of my presentation, I mentioned manipulation of data and people trying to make the numbers look as good as possible. And so it's a good time to come back to that. Planned downtime can be one of the most contentious variables when monitoring OEE. Different people have different ideas about what should and shouldn't be included in planned downtime. So for me, non-work shifts are clearly planned downtime. So if I'm running 5 days a week and I don't run the weekends, those non-work shifts are clearly planned downtime. But what about tea breaks or maintenance, no orders, no operators? I've heard many compelling arguments for and against including these as planned downtime. I've been in many meetings that have gone on for 3 or 4 hours where people have discussed and argued about what should and shouldn't be included. And the motivation for those arguments is always really, you know, trying to make or trying to give themselves, put themselves in the position where their OEE number is as high as possible. And again, it comes back to you know, the whole purpose behind OEE, and not using it as a big stick against your workforce, but, you know, looking for a genuine number that you can then make improvements on. So, you know, I don't think there's anything wrong in adjusting what might be defined as standard practice to fit OEE into your personal situation, but ultimately, I believe the harshest measure is best. I think you should absolutely minimise planned downtime. You know, look at any planned downtime category and ask yourself, is it an opportunity to make something? You know, if you set tea breaks, for example, as planned downtime, you know, maybe that will lift your OEE by a few percent. But are those breaks actually an opportunity to make something, to make your equipment more effective? So again, don't focus on the number, focus on the improvement to that number. So I've put some numbers into each box on my staircase just to bring a little more context. So I'm considering here one piece of equipment for 1 week. So my total time is 168 hours in that week. Now, I don't run the weekend, so I've got 48 hours of planned downtime. So my available time, sorry, is 120 available hours. Now, of that 120 hours, I actually only ran the machine for 108 hours. So I had 12 hours lost to unplanned stoppages. So my availability was 90%. And of the 108 hours of run time, I only actually earned standard time produced of 103 hours. So I've lost 5 hours to running the machine slowly, giving us a performance of 95%. And then I also had some scrap. So I have 3% scrap, I have a 97% quality rate, and so I've lost 3 hours due to making scrap. So my 103 hours of standard time produced, actually only 100 hours were making good parts. So of my 120 hours available during the week, I've only actually made 100 hours worth of good stuff. So each of our KPIs are very good, they're 90% plus, but it gives us an OEE of just 83%, which is pretty good, not quite world class. But looked at another way, we lost 20 hours of potential output in 5 days. So we've lost almost a day's worth of output in just 5 days. You know, and I think that's a very tangible message. So where do we go from here? Well, the next step is to look at those losses. What were the biggest causes of downtime, biggest causes of scrap, and so on? Isolate those problems, address them, and then measure the improvement. But that's probably sort of further discussion for another day. I'm just about out of time, so that's me. It's a brief overview of OEE, why and how you should use it. Just enough time, hopefully, for a shameless plug of InTouch. If any of you are interested in automatically monitoring your OEE or got any other MES requirements, then I'll be happy to hear from you. We're even doing a free trial at the moment, so there's nothing to lose. So thanks very much for your time. Thanks for listening. And I will now hand over to John.
Thanks, John. So, yeah, next slide, please, John. So I'm going to go on to talk about the advantages of predictive remote monitoring. My name is John Hill. I'm the Chief Operating Officer of in-vendor managed assets, or InVMA. Next slide, please, John. So I'll start with a plug. InVMA, the one-stop shop for companies embarking on digital transformation, and basically we connect the physical and digital worlds to transform industry. We've got our own product, Asset Minder, which is used for primarily condition monitoring, but also providing utility and other performance management data. And we're also a value-added reseller of PTC's ThingWorx platform. Next slide, please, John. So in the next section of the presentation, we're going to be looking at the top one of those items, improving availability of the equipment. We're going to explore failures and different types of maintenance for supporting that. we're going to see why the balance is moving from reactive and planned maintenance to predictive and prescriptive maintenance to improve OEE. Understand new technologies that make this possible. And then I'm going to hand over to Alan Findlow from Haley 247 and the DMS's Machine Guard, which is powered by AssetMinder, where Alan will take you through some real case studies, some reality of how the types of improvement that have happened in the area of maintenance, and then we'll go on to the conclusions of the process overall. Okay, next slide, please, John. So typically, if you had a typical OEE of around 55% in a sort of poorly maintained environment, you can see, as John was speaking about, the quality 91%, so productivity 85, gives us a low OEE of 55%. Please click ahead, John. And if you look at that from a return on capital employed, so this is one, and I used to be a bean counter, so I can say it, one for the bean counters. The OEE has a direct contribution to the return on capital of the machine. Basically, you've paid for a lot of capital, which is sat at idle. Next slide, please, John. But increasing the OEE by 7 points puts through an increase in availability, which then has a direct consequence on the return on capital. If you go to the next one, John. So you can see we're almost, we're increasing significant improvements on the on profitability and therefore return on capital by small movements in availability. This obviously assumes that you've got, that you can sell the produce that you're producing. But this is generally what we find, is that small movements in improvements in availability and the impact that has on the current productivity and quality that you're getting has a significant output on the return on capital. And can easily justify some of the investments that you're making on the improvements. Next slide, please, John. So the 4 types of maintenance are reactive maintenance. This is where you literally, the old break fix, or the smoking maintenance as we call it. Preventative maintenance, where you're using the outputs from a normally from the OEM that's provided the information for you to do servicing. The second one is predictive maintenance, where you're actually using the data from the machine itself to predict failure. And then finally, on prescriptive maintenance, where using the data from the machines to actually prescribe and tell you what it is that needs to happen so that you can plan and put that in place. So go on to the next slide. The case for condition-based monitoring is pretty straightforward, is that for some manufacturers, some of the research we've done shows that 10% reduction in maintenance costs is equivalent to a 40% increase in sales on the factory P&L. The best overall equipment effectiveness is 97%. World class is 83 or 85, that sort of area. The average is about 66. What this means is nearly a third of the investment that a company has made in capacity in its assets is wasted. So much of this waste is driven from poor quality or unplanned downtime, as we've seen. However, machines really do give plenty of warning if they're in distress. Their vibration signatures change, their oil quality maybe changes, they have temperature starts to change, they start to run hot, pressures, if they're required, behave differently as well. So there's a lot of input into that there's something that's going wrong. Next slide, please, John. So really the key here is that by moving towards a predictive, away from a reactive route, means that in a normal reactive process, the asset develops some sort of abnormal health condition, you get an andon light, an operator notifies maintenance, you get some form of work order, or they get called to, maintenance get called to the machine. There's a review of the sensors, there's a review of the situation, troubleshooting, remediation task is done, and then there's some verification. So yes, and then you've got the machine back and running. In the predictive cycle, the first thing is the system starts to identify there's an anomaly. The experts get involved very quickly to start to assess what the impact of that anomaly is and whether that's something that's going to be happening now or something to be considered in the future. This is before an andon light comes on. You can do an online review of the sensors. This can be done locally or indeed remotely from the OEM themselves or for some third party like Haley 247. And that enables them to help you debug what's going on with the machine, troubleshoot it, and then plan in the downtime or the maintenance potentially at, for example, a changeover or switchover or some other planned activity. So it significantly removes the disruption and the unplanned downtime, which we saw right at the bottom of that pyramid. Next slide, please, John. So if it's so obvious, I mean, the case is obvious for this, you know, a third of wasted capacity in manufacturing, and the fact that we know that we can get all this data from our machines. So what's been the problem in the past? Well, it's been CapEx. To get the data out of these machines and connect to them has historically cost a lot of money. Even then, you have to then go and do the installation. And if you're doing any condition monitoring, you normally have a person in a van coming around with a condition monitoring, vibration monitoring, vibration sensors or accelerometers to identify if there's a problem. There's also the physical access, the irony of having to stop production to get access to fit these sensors. And then finally, it's the sort of the skills, the interpretation of the data. And the aging workforce retiring means that you get your expertise has been going out the door. But also as well, culture where reactive is rewarded. And technically, there's not been that much confidence in the technology. And so that's what we've seen has been stopping people. But a lot of those barriers have now been addressed. Next slide, please, John. So what's been happening over time is that the world of industrial automation, or OT, operational technology, and the world of information technology have started to converge, which is removing some of those cost barriers. Bluntly, the investments that have been going into the handhelds and mobile devices are finding their way into machines. So the first things is that a lot of original equipment manufacturers now offering connected machines where they're shipping assets and machines with a rich array of sensors, and they're starting to use open and standardized protocols such as OPC UA, which is self-discoverable, and MQTT. These have been around for a while, but are starting to become present in most high-end machines that are being sold. What this means is the data is ready available and you don't have to do any retrofit. Also, the edge gateways, these are industrial gateways that can connect to those machines to provide you connection to other cloud and analytics platforms, have become ubiquitous and very cost effective and also secure. And the availability of wired and wireless sensors is making getting hold of that data very, very straightforward. Going across the top, industrial innovation platforms like PTC's ThingWorx and platforms similar to that, and enabling companies to not only connect up the data from their machines, but also connect it into their current infrastructure of their MES or similar systems. Getting access to the data as well is very straightforward because most people have got some ubiquitous human-machine interface or their handset, their device that they've got. But similarly, we're also finding now that devices such as RealWear and the Microsoft HoloLens are starting to also put that into people's hands, if you like, but without using up their hands, so they can basically see it through their visors. Wireless sensors and protocols mean that you can retrofit very, very cost effectively without having to have that disruption on production. Getting data out is very quick now with 4G and now 5G networks enabling large amounts of data to be shipped cost effectively and without the need to interfere with on-premise or the current IT infrastructure. And finally then, in terms of the areas of predictive maintenance, intelligent machine learning is automatically is enabling the systems to automatically identify anomalies and also identify where they've seen these types of situations before to help produce predictive outputs. And finally, we're all getting used to remote working now, and there's also the ability to start to have access to augmented reality operator assistants to enable expertise off-site to provide guidance to people on-site. So that's removed a significant amount of the barriers that we've had in terms of deploying this technology on the basis of cost and ease of deployment. Next slide, please, John. So with that, I'm just going to hand over now to Alan Findlow, from Haley 247 Drive Management Services to take you through some real life examples and their product.
Thanks, John. Right, good afternoon, ladies and gents. Welcome to the power of predictive maintenance. And as John said, and John prior to that, we're going to give you some real life examples where condition-based monitoring in the new world using IoT and the power of IoT is delivering real costly savings and benefits. Next slide, please, John. So we're going to play a video, so you won't hear me talk now for approximately 2.5 minutes while we play this video, and then I'll continue the presentation. Can you play it, please, John?
John, I think you have to go off unmute.
Millions of pounds in lost revenue due to unnecessary downtime. We work closely with every client to identify their critical assets and outline the best way to apply the Machine Guard solution. The easily installed gateway can accept data from a wide variety of sensor types, including our cutting-edge Bluetooth vibration and temperature sensors, suitable for use on any critical rotating or reciprocating equipment, including gearboxes, electric motors, fans, pumps, and much more. And because it's a wireless solution, installation is quick and efficient. Streamlined access means any internet-connected device can be used to monitor critical assets via the AssetMinder cloud-based platform, a powerful 24/7 managed monitoring system providing alerts that can be triggered using the format best suited to your business. From a single site to a global operation, Machine Guard, powered by AssetMinder, can provide the kind of all-encompassing protection your organization needs. Remotely identifying imbalance, misalignment, mechanical and structural looseness, layering and gear damage, lubrication starvation, cavitation, and other potential issues. Welcome to the power of predictive maintenance.
Right, John, if you can go to the next slide, please. So, as was describing there, gentlemen, what we've got here now is the future, but it's today. We've got installations now in the UK, probably on over 100 sites, monitoring some of them in excess of 1,000 assets. So the criticality of some of these assets, particularly like in your sector, in the plastics sector, is pretty important. And we've got the capability now to make things simple, effective, but to give real quantifiable data that enables us to make these decisions you see here. So we can fit Bluetooth accelerometers that are recording the data seen before, quickly transferring the data via Bluetooth, and then it's up on the platform on the actual AssetMinder platform, where we can then look at the trends, look at the spectra, and actually work with the client to actually put a plan in place to enable him to ensure that no lost production is incurred, or if it is, it's got some control mechanisms in place. Next slide, please, John. So, just talking about our BlueVib accelerometers, the beauty of these, they can be installed in minutes. There's no wires. We can drill and tap. We can use a 20 kilo pull magnet, or we can use hard epoxy, and they can be installed on your asset in a matter of no time at all. They're IP67 rated for particular harsh environments, and we do a lot of work in environments such as quarrying, steelworks, water treatment, where the environment is pretty harsh, and these stand up to them rigours. It enables the asset to be monitored continuously, or, if we want, on exception. They use low power battery operated under a AA lithium based battery, which can be replaced. So the battery life, generally, depending on how often the data is sent, is anywhere between 12 months and 3 to 4 years. It uses the latest version 5 Bluetooth communication, which enables us to optimize that battery life and increases the actual data transfer speed. And generally, they can collect the data from up to 50 meters away in heavy industrialized areas, such as your type of sectors. We have an ATEX version as well for hazardous areas, such as gas, fumes, dust, etc. Next slide, please, John. And the beauty of these sensors, immediately we've got outstanding capability. They are manufactured in the UK under license to us, and straight away these sensors can produce as the headline news, such as RMS velocity, RMS acceleration, the peak-to-peak acceleration, the temperature and battery life. So they're the headline news that they're straight away. But the key things to us as a condition monitoring company is we're getting real high value spectra data up to 10 kilohertz. So we're not just looking at the low end at 0.3, we're also looking at the high end. So when we're doing our analytics, it gives us almost a sensor that's actually better than majority of sensors used by handheld data collectors. We've got various sensitivities available from 25 millivolts per G all the way up to 500 millivolts per G for real slow speed applications. And the sample rate is pretty incredible, up at 25.6 kilohertz. All the other technical data there, although it doesn't mean a great deal to you guys, what it means to us as data analysts, it means that when we get this data in, whether we're looking at the low frequency or the high frequency, we can make decisions that are going to be extremely accurate. And in effect, it's like having one of my data analysts sat on your machine with a handheld data collector every minute of the day, taking data and actually performing some analysis on it. Next slide, please, John. The gateways, as John mentioned previously before on his slide there, within VMAs, we use various types using predominantly the Technexium. We have used Dell in the past, Treon and Applicom, but these enable us to have pre-configured gateways that can connect remotely, and it gives us the capability to amend these configurations and add additions very quickly. So, for example, we've got clients now who have a number of the sensors and gateways on site, and every time they want to add a new asset to it, we can actually send the accelerometers via a courier, and we can remotely dial into the gateway, add the new configurations, the new settings, so when the sensors are fitted, immediately they are talking to the actual platform. They have we have the best and most reliable gateway in the market with the highest mean time between failure, and we have each gateway is capable of communicating with approximately 250 BlueVim accelerometers. So generally, it's almost you've got the ability to not even have to worry about the additions all the time, because it's very rare that you get to a point where you need to have more sensors than the gateways. We've got a real small footprint, so you can see the size of the enclosures there are generally 400 by 300. So it's very neat, it's compact, and it's obviously built to the highest standards. Next slide, please, John. The big advantage for us as a business now is, as both the two previous Johns in their presentation we talk about, the most important thing for us is data from your machine, what that data tells us. We're concerned about the actual machine health. So the more data we can put into our system, so whether that be oil sensors, pressure, flow, speed, temperature, on top of the vibration, starts to enable us to build a picture where we can start talking to you guys with confidence and say, right, on your extruder gearbox, this is the issue we've got at the minute. This is what we're seeing with the data coming through. You may need to have to back off that particular production line. I know I'm going against the OEE side sometimes, but if you need to get that machine through to a particular production window, then if you do this, we can get there and we can control the actual downtime. On to the next slide, please, John. Remote support. What we've got now in the UK is we've got what's called the European Diagnostics Centre based in our Technology Centre at the Advanced Manufacturing Park in Sheffield. This is built, as you can see from the photographs there, on the old Orgreave coal mine. So if the people remember the Battle of Orgreave from the original National Coal Board days of the miners' strike, that's where we're built. And we have a team of diagnostic engineers, not just out on site, but actually permanently based in the office. And we're providing support throughout the UK now, and not just the UK, but into Europe on remote installations and settings. Next slide, please, John. So what I'm going to come on now is just going to show you a couple of examples, and this quick slide here just shows you some installations where we've got them at the minute. Everything from cardboard corrugating to water treatment to remote pumping stations to automotive production lines to RAF, aerospace fuel pumping stations to mineral processing to material handling in ports. Basically, you name an industry sector now in the UK and we all have an installation in one of these sectors. Next slide, please, John. So the first case study I'm going to show you is in a limestone quarry and milling facility in the UK. They provide limestone to the steelworks, to the water treatment plants. And what we saw within a matter of weeks, we were getting alerts via email sent to ourselves. And the big advantage of us being a service provider is we get the same alerts that all our clients get. So whether you get an email, whether you get the SMS or even voice synthesis, my team of engineers get the same alerts. So we started to look at the stack fan up on the 4th floor of what's called the Hydrate building. And we've seen the data, and when we're doing the analytics, we said to the client, listen, we believe you've got a loose motor. The client got one of his maintenance guys to go up there, and what he found on arrival was that the back two motor holding down bolts had come loose. One of them had no nut at all, and one had one that was completely loose. They tightened them down, and straight away, as you can see on the trends on the right hand part of the slide, the data just returned down to well acceptable levels. Next slide, please, John. On its sister plant on the other hydrate, we installed it then in what's called the microset fan, which is a critical fan. If this fan fails, this complete production facility, milling facility, can no longer produce. And what we saw from the alerts when we were doing the analytics was we were seeing cage defects and harmonics in the actual spectra, which normally means we've got the onset of bearing damage. So we spoke to the client, we explained this to him, but his issue was they had a massive production run and they didn't want to stop until the second week in October when they had a maintenance window planned. So what we agreed is every day we would analyse this, work with the client and ensure that, you know, we would oversee and try and get through to this thing. So we'd inform them, put some more lubrication in, we keep an eye on it, close eye on it, and then we work really close. So if you go to the next slide, please, John. What we saw over that period of time, once they got to October, was we managed to bring the bearings down to an acceptable level, and the client was absolutely over the moon. And ever since then, this particular client now has got 7 installations on critical parts, from ball mills through to vertical pendulum mills, etc. Go to the next slide, please, John. So based on what the guys were talking before and linking into the OEE, the big advantage for us now is if you start to look at the cost of some of your production facilities and how much lost production is, and then you look at the type of cost in one event, you can see the kind of payback that can be achieved by installing one of these types of systems on a critical plant. So it's really, really imperative that some of our clients look at this sort of data, and you can actually see critical return on investments. So whether that be a simple system consisting of 6 Bluetooth accelerometers and a gateway, the data we can produce and the analytics we can assist you with is absolutely cost effective. Next slide, please, John. So what are the benefits? The benefits we use in our kind of platform and the Asset Minder using Machine Guard is that we've got the remote system adjustment using the inbuilt Kepware and Ubuntu on the gateways. It means that additional sensors can be added quickly and professionally. All types of sensors can be monitored in systems on our, such as oil condition, oil temperature, using a patented oil quality sensor called the TAN Delta. We can measure flow, pressure, running speed, ultrasound sensors. And this enables us to monitor the all-round condition and health of the machine, so not being restricted by the traditional condition monitoring sensors like a lot of their competitors do. The big, most simple and most significant benefit to us as a business and to you guys, the end clients, is in the old days when we used to install systems with hardwired sensors, part of the biggest cost was actually on the actual installation of the labour. Now with the Bluetooth accelerometers, the ease of installation is massive. We've got ease of setup, remote setting adjustments once they're installed, but the reduction of on-site labour is probably 80% reduction. It is massive. We've got excellent system analytics from real high quality diagnostics, and we've got the remote diagnostic centre here to support our clients. Next slide, please, John. Going forward now, and working with John's team at InVMA, and that's why we're a true partnership, is what we're looking to do now with our AI, our artificial intelligence. We've got automated threshold setting and anomaly detection that's going to enable us to find real-time anomalies. It will enable us to observe and have kind of machine learning in normal state patterns, and we're doing some testing at the minute with electrical signature analysis, doing the same thing. We've got no need for setting rules or kind of applying predetermined calculations. We can actually have that automated by the system. And what we can do is deliver true alarms based on what we're seeing. So when we're making decisions, it's real live data that's allowing us to talk to you guys, the end client, and say, right, these are the decisions you need to make, quantifiable decisions. Next slide, please, John. So, what's machine learning going to do? It's going to enable us to predict the time to failure, and it'll enable us to apply this machine learning not just to current data but to historical data. So then what that starts to do is enables us to predict about future outcomes. So if we see this particular change in the curve, in the trend, then we can make a decision and talk to the client, and they can make insightful decisions based on intelligence that will actually improve the OEE on plant and actually reduce the downtime, which is it's the marketplace we're into. And it's about completing that circle from going from where clients have been historically in reactive to actually being in the prescriptive field and making that transition along the way. Next slide, please, John. So as you can see, as we move forward now, we go from descriptive, what's happened. We then look at the diagnostic aspect. That's where we come into our own, doing root cause analysis. Why did it happen? We then look at the predictive, what will happen if this occurs? And finally, where we want to get to and where most people at the world-class OEE want to be at is prescriptive. What should I do? That decision support and that kind of automated decision-making where the AI and the machine learning will actually give you a warning, not just, guys, there's an alert, this is going to happen. It's, here's an alert, this is what could happen if you don't make these changes. Next slide, please, John. So finally, just to summarize, predictive and prescriptive maintenance is more cost effective than reactive for any critical asset in any sector. The historical barriers and obstacles restricting clients from using this type of technology is now slowly being eradicated with reduction in sensor costs, equipment, installation and servicing costs. The new sensor technologies such as the Bluetooth accelerometers that we've just been showing you are extremely powerful and are definitely on the cutting and not bleeding edge of technology. They're accurate and they deliver real precise and sensitive data. And the important thing is the more sensors are being manufactured, like anything in life, gents, the costs are going to come down with volume. By integrating various types of sensors, and we use the assets existing inbuilt sensors, like John said, coming in on the equipment, we're able just to understand the machinery health of everything and avoid unplanned downtime. And we've got a team of real highly trained condition monitoring engineers who can analyse the information and provide real on-time advice when it happens and when they don't have to be on site to provide that. The majority of condition-based analysis will be automated, eventually reducing the number of false positives and negatives. Next slide, please, John. So finally, our offering is based around our service. like we said previously, the majority of competition are equipment manufacturers. So they're more interested in selling the equipment. They don't have the same service ethics that we do. That's part of our DNA. We're a 24/7 business doing everything from reacting to being prescriptive. Our people are our strength, highly qualified diagnostic engineers employed to support all our global clients. And that's the most important part of our business, because sensors will change, sensors will develop, but the important thing is our people. The case studies we presented today demonstrate how highly developed IoT technologies enables our people to deliver real quantifiable savings and results. And this remote monitoring, as it develops, will enable us to all be regularly in touch with our clients, so we become a true partner without necessarily being on site all the time, delivering a real value-added service. As the technology develops further, we'll be able to implement the machine learning on various machines. This will provide machinery health data, which is far above and beyond the traditional monitoring methods. So welcome to the power of true predictive maintenance. Thank you for your time.
Okay, so thank you to both Johns and Alan for the very interesting presentation. We have had some questions coming in from the audience, so if I could ask the speakers to put their cameras on when they feel able. First question is to John Hardwick, and it's about planned downtime. Why not then include this proportion as part of an OEC calculation to also address for analysis and improvement? John, I think you're on mute.
Sorry, I would say I'm not sure I fully understand the question. Can you repeat it?
Yeah, so in terms of planned downtime, why not then include this proportion as part of an OEC calculation to also address this for analysis and improvement? So why not put planned downtime as part of the OEE calculation?
Well, I guess you can. It's part of, I guess, what I said. You know, you can tailor it to your own requirements. To look at the standards. Now, if you take downtime out, then it will give you a really, really low OEE. And if you're not planning to work weekends or nights, if you're only days a day, 5 days a week, then base your OEE on all time frame, then you could be down possibly 20 hours a motivated workforce. And I know I said, you know, you shouldn't focus on the number, but even then, telling your guys, well, you know, our OEE is down, it's possibly not going to be the most motivational. And it's not something that the guys on the shop floor are doing out. And I think if you actually if you start looking into it even more, there is a measurement, I think, called TEEP, total equipment effectiveness, something, I'm not sure, without checking, which does take into account all time, so a different number. So I'm not sure if that's answered the question or not.
Well, I hope it has, but if not, Fred, then I will make sure to get all the information across to John so that he can get it in detail if necessary. Now, the next question is for John Hill. Now, you touched on this as part of your presentation, but one of the concerns is about security and internet security, getting all the information online and that kind of thing. Can you touch on that at all?
Yeah, I can. It's actually the first question that customers ask me before price, so I'm not surprised about this. Two things. There's one on the installations. What we find is that there's two levels. One, initially, where customers just want it separate to their own network. So we don't put it on the industrial network. We use a gateway that's connected direct to the DMS Asset Minder platform. And that means then we're using a lot of encryption, transport layer security, but also we rotate the different keys that communicate between the gateways and the platform. terms of data security, we try to, with the customer, encrypt the data at rest, so it's stored separately. You can, and we also do penetration testing on the platform as well, and also through our customers from the gateway to the platform. So that's the only way to go with security. It's a significant question. It's a good question, and needless to say, we've got a lot of papers on it, which we can share with your IT teams to work through that.
That's
so I take it very seriously, and it's a lot of patching and a lot of keeping up to date and whatever. But we design it in from the start because you have to.
fantastic. A quick one for Alan. So I have muted you, Alan, because we had a bit of feedback. So I'll just look to unmute you now. Just a very quick one. What's the kind of life expectancy for one of your sensors?
Life expectancy is like most electronic pieces of equipment, up to 10 years, I would suggest. Depends on abuse and negligence on site base, but generally we've had these sensors now installed for over 4 years, and probably performance-wise, I say we've probably got about 99% quality aspect. So yeah, we're pretty pleased with the performance.
I think you'd be pleased to know as well, we have predictive maintenance on the predictive maintenance. So we're monitoring the gateways and the sensors. We look at the battery life. We warn people early if the battery looks like it's going to go flat. So that's you don't want to miss something because your predictive maintenance system is down. So yeah.
That's fantastic. And sorry, was one of you wanted to
No,
speak?
I was going to say it would be quite ironic if that was the case, wouldn't it?
It would be quite ironic, but perhaps a little bit embarrassing. So I'm glad that it won't happen. It won't happen. That is actually the last question that we have had. We're coming up to 1 o'clock. So I think at this time, I'm going to say thank you to John, and Alan for presenting today. I think it was incredibly interesting. You've got their email addresses all online. It's on the screen now. We will be sending out PDFs of the slides. We'll also be making a recording available. So if you found this interesting, but there's someone in your organization who you want to see this recording, then you will be given a link so you can spread the love. I'd like to also mention that recordings of all of the BPF webinars that we have been doing, and that's well over 100 now, are available at bpf.co.uk for BPF members. Alternatively, email events@bpf.co.uk for more information. We have more free webinars coming up from the BPF. Our next webinar is on the topic of an overview of mergers and acquisitions, buying and selling companies, and that will take place on the 11th of June. So we're taking a little bit of break for half term. And my final point before I say goodbye is that when this webinar closes, a short 5-question feedback form will launch. I would ask you, if you have the time, to fill in this form so as to help us to keep improving the webinars and make them even better going forward, if that is indeed possible. So finally, John, and Alan, thank you so much for today. Really appreciate it.
Thank you.
Yeah, thank you.
And wishing you all a good rest of your day, and goodbye.
Yeah, thank you.
Bye. Thanks very much.